Ladies and gentlemen, dear colleagues, it's an honor and a pleasure for me to give you an update on the revision of Eurocode 3. The subtitle, Evolution by Improvement and Harmonization, already indicates the aims of this revision, and I will come to that a bit later. First, I'd like to acknowledge that a number of co-workers, and of them especially Christina Schmidt-Rasche, helped me with a presentation as well as with a belonging paper. Let me give you a short overview on my presentation. In the first part, I want to give an introduction on the revision and further developments of Eurocode 3, something about the organization of subcommittee 3, and explain the procedure for the revision of Eurocode 3. In the second part, I will give you some in-view in selected code rules of the part of Eurocode 3 as they are given here. This gives you an overview on the structure and the overview on the existing Eurocode 3. So there are 12 general parts, for example, part 1.1 on member stability, or part 1.8 design of joints. And there are 8 application parts, for example, part 2 for steel bridges. And the application part form a kind of master for the use of the general parts and of other Eurocodes, such as Eurocode 1 for loading. Let's come to the aims of the revision, and this, of course, not only for Eurocode 3, but for all Eurocodes. First of all, we want to include the latest developments, that is, new materials, new products, new methods, and new market requirements, and for that it needs an extension of the existing rules. Secondly, we aim at improvement and harmonization of existing rules. This is expressed by the term reduction of nationally determined parameters in NDP. And thirdly, and I think this may be the most important one, we want to achieve an enhanced ease of use of the existing Eurocodes. For example, by improving the clarity, by simplifying the rules through the Eurocodes, limiting where possible the inclusion of alternative application rules, and avoiding or removing rules of little practical use in design. Let me give you some examples. So the part 4.3, with the existing part 4.3 is on pipelines, and we have decided to withdraw this part. Why? There are many other EN standards for pipelines with more specific purposes, and it really seems that this standard is not much used. However, when we decided to withdraw part 4.3, it was found out that there is at the moment a national annex from Austria where there is content which is really of use. The content concerns Penstocks, that are high pressure water pipelines used in hydraulic electric applications. And this, of course, we try to keep, and for that we identified a technical specification to contain this new content. So we enhanced ease of use by avoiding or removing rules of little practical use, but at the same time we try to keep valuable content. Second example is the merge of Eurocode 3 part 3.1 and part 3.2. In fact, the idea is to have one single part, tower, mast, and chimneys. Why? There are a lot of common sections of these two parts, and it is not a clear differentiation between the tower, mast, and chimneys. So it makes much more sense to have one family of tall, wind-sensitive structures. And this is, of course, an improvement and harmonization, also a reduction of national determined parameter, and an enhanced ease of use. The third example concerns part 1.12. Part 1.12 at the moment gives additional rules for the extension of Eurocode 3 up to steel grades S700. we decided to dissolve part 112 and integrate the content into part 1.1, part 1.5, etc. So, for example, part 1.1 has been adapted of the requirements on the ductility and for plastic design, and there has been an extension of buckling curves. So this is for sure, again, an improved clarity. However, when we had decided to dissolve part 112, we identified a new need. So there is a new high-strength steel up to S960 where rules are missing. So we decided to have a new scope and a new title for Eurocode 3 Part 112, allowing for an extension of the rules for steel grades stronger than S700 and up to S960. And with that, of course, we also allow for latest development, and we open the door really for this new material. Let me explain a little bit on the organization of Subcommittee 3. Subcommittee 3, within the family of TC250, is responsible for Eurocode 3, design of steel structures. Within Subcommittee 3, we have identified for each of the single parts of Eurocode 3 an individual working group. So, for example, there is the working group 1. Convener is Bert Snyder from the Netherlands that deals with Eurocode 3 Part 1.1. Or there is working group 5 dealing with Eurocode 3 Part 1.5, and I'm convener of that. And the task of this working group is technical clarification. The members of this working group are experts nominated by their individual national standardization bodies. So what we achieve is has two sides. So on one side, we really gather for a certain subject the experts in Europe. And on the other side, as the experts are nominated by the national standardization body, we really also achieve an acceptance in this country. So if a proposal for a corrigenda or an amendment is coming to Subcommittee 3, then Subcommittee 3 gives that to the relevant working group. The relevant working group discusses this proposal and makes a recommendation. The recommendation is then finally decided in Subcommittee 3. And this procedure, the same procedure, is also done for all the technical changes to be implemented into the new version of Eurocode 3. This is our list of the 22 working groups. You see at the left hand the list of the single parts where they are responsible for. There are general parts and application parts. The numbering is given on the right-hand side and the current convener. Let me come to the general procedure for the revision of the Eurocodes. So the existing Eurocodes, more or less the content date from 2005. This is already quite a long time. So it makes absolutely sense to have a general revision and a maintenance of these parts. There was a call for systematic review where the single countries could make proposal and ask for changes. And this systematic review has been elaborated or has been commented by the subcommittees and the relevant working groups. This is one side of the part of the revision. The other side consists of the mandate. So the Commission has given to SEN a new mandate for the revision of Eurocode, of the Eurocodes. So it's not only Eurocode 3, it's all Eurocodes. The number mandate M515. And within the mandate, contracts are given to project teams. Project teams consist of 5-6 experts of different countries, and they really develop the new text. So they have a certain task, they have a contract, they even get a little bit of money, and they have a time for delivery. And if, for example, now the subcommittee and working group has developed a new modification. This modification is given to the project team, and the project team will implement or has implemented these changes in the new draft. Here you see the list of our project teams. There are 13 project teams altogether, and some of them are responsible for more than one part. You see also that this project team belong to certain phases. So the whole mandate is distributed on 4 phases. And we on purpose decided to have Eurocode 3 Part 1.1 and Part 1.8, so the basic parts in phase 1. So that all the other coming parts, that they know already what has been revised in Part 1.1 and Part 1.8. For example, for the application parts, which are in phase 4, it is really important they do not repeat the general part, but can use what has been written in the general part. This gives an overview on the publication plan. This is, of course, again, not only for Eurocode 3, the procedure, but for all Eurocodes. And by the color, you see the different groups which are active and their task. So there is a red box which symbolizes the work of the project team. At a certain point of time, the project team ends its work, it gives the document to the blue box, and the blue box is the work of the subcommittee. For example, for Eurocode 3 Part 1.8, the project team finalized its work in March 2019. The subcommittee then tries to get a consensus on the content of this draft, modifies the draft, and gives it finally to TC 250 for the formal procedure. Then comes, very important, the so-called SEN inquiry. This is a public inquiry on that draft. And the countries, the different countries can say yes or no, accept or not the draft, but very important, they also can make comments. And based on this comment, and this is again the blue box, the subcommittee or the working group in the subcommittee modifies the draft. This modified draft goes again back to TC 250 and to the formal procedure. So it then comes the next inquiry. This is the so-called formal vote. Again, it's a public inquiry. The different countries are requested to give their opinion, whether they accept or not accept the draft. However, in this case, it is not possible to suggest any technical changes. In the sequence, there are some editing issues, and then, only then, the draft is given to the national standardization bodies, which is symbolized here with the green box. So for Part 1.8, that will be in 2023, March 2023 probably. And the national standardization bodies have to draft a national annex. They have to translate and publish the draft and withdraw the old draft. This is an overview concerning all the deliverables within subcommittee 3, and you see here the timeline for Part 1.8, which I already showed. I think this is very helpful for all the revisions we have with the different drafts, with the different parts, and we also open for all the different parts the possibility to have an inquiry. So each draft has run through an inquiry or several inquiry, and there are answers to the comments which are documented. So I think we have really a very good transparency through the whole process. It is documented not only the background by the project team, but also all the decisions within subcommittee 3. And by that, I think we really achieve the utmost consensus which is possible. So it needs quite a long time, yes, but by that I think we really get finally an agreed draft for the revision of Eurocode. Let's come to some more specific rules. I'd like to start with Eurocode 3 Part 1.1, General Rules and Rules for Building. This is the furthest in the whole procedure. So we had the Sen inquiry, we had comments from the Sen inquiry, they were answered and the draft was modified. And now we have a positive decision to send the draft to formal vote. Formal vote probably will be in April 2022. So I will give you a short in-view on the changes, but only a few. For me, it is very important that there is a certain simplification of the stability rules, and also that we achieved a unification of the rules between this general part and the application part. This is especially obvious for the rules of lateral torsional buckling. You see here the famous Annex A. You know, in the existing code there was an Annex B. I originally counted about 7 different possibilities within our existing Eurocode 3 Part 1.1 to have a verification on lateral torsional buckling. And by a new development in this area, we really achieved a reduction of these numerous alternatives. I think about 3 are left over. So I think this is really a big improvement. Very important in this is also that we define a certain method of analysis. This is what connects the calculation, the analysis, the calculation of stresses and internal forces, first order or second order, with a verification. And we identified 6 different methods. So there is method 0, which is the simplest one, only calculating first order theory, no imperfection, and a simple resistance verification. And these methods, they are ordered according to the complexity. You see on the right-hand side this flow chart, and this gives this this order, this criteria to choose a different method. So, for example, the most complex method, M5, has a second-order analysis in plane and out of plane, including lateral torsional buckling and all imperfection, and then the verification. So I think this is really a clear improvement in view of clarity and simplifying rules. Another new point in Part 1.1, which I think is of importance, especially in view of transparency and background, is this new Annex E, calibration of partial factors. It contains the most important assumptions and procedures on which the calibration of the partial factors for buildings is based. It is not intended to be used directly by the practice, but it is meant for the mirror groups to decide on the partial factors. It is based on a European research project, Safe Bractile, which developed recommendation for the partial factors, but also developed the whole procedure, and it lays down the assumptions behind. So I think it really contributes to the transparency of the whole procedure. So here you can see the assumed variability of the material properties as well as the assumed variability of the dimensional parameters, which are laid down as background. So any mirror group can decide whether they follow these assumptions and the partial factors or have their own input in that. Let's come to Eurocode 3 Part 1.8, design of joints. Here we have had really a 100% approval in the Sen inquiry, but about 700 comments. And it ended end of June this year. So now there is a reference group in working group A dealing with these comments, modifying the draft to be sent at the end also for formal vote. Also here we try to have ease of use by restructuring the whole content. So the original section 5 and 6 were split in more general topics, which are now laid down in section 7 and 8, and more specific content like, for example, resistance of the components or the stiffness of the components, which can be found now in the normative annexes as they are given here. We also have an enhancement of existing rules for Part 1.8, for example, concerning bolted connection. There is a new calculation of bearing resistance. There is a new nonlinear model to calculate the deformation of the bolt hold. And we also added threaded holds, the rules for threaded hold, which were not in the existing code. Also for welded connection, there are new rules, especially in view of high-strength steel. So there are given new correlation factors for this high-strength steel, which achieve, as you can see here by the diagram, a much better resistance as it is at the moment. At the moment, we have, for example, S460, a smaller resistance as S335, which is not very logical. So here, really new new information could be implemented. We also allow now for clearly under-matching and over-matching connection, which is important for high-strength steel, by a new resistance, which also consider the filler metal. So also that is new content, new information, and more possibilities for the future. Let's come to Part 1.5, plated structure. So plated elements. Here we have fully accepted this procedure I explained at the beginning. So there are quite a number of new developments which were discussed in Working Group 5. New amendments were developed in Working Group 5 and finally decided in Subcommittee 3. So here you see there are about a list of 25 new amendments which already could be given to the project team so that they could implement that in the draft. You see here the list of content, for example, patch loading or interaction for MV or the rules for tapered panels, as you can see here also in the test figure on the right corner. SEN inquiry will start for Part 1.5 already, I think, in March next year. And also then I think we have the chance really to have an improved draft. So example, also in improved structure, we try to implement the context of the different annexes into the main text. And we also achieved a really great reduction of the national determined parameters from 15 to only 3. This is, of course, a big achievement. Also concerning this reduced stress method, we improved very much. So I must admit that at the moment, this method is only used in Germany or German-speaking countries. Probably because what is written in Eurocode 3 Part 1.5 on this method is not very consistent and is not very clear. And if you do not have a German textbook how to use this method, it becomes very difficult. We now have a complete restructuring of this section and a flowchart, as you can see here. So I think this really gives more clarity and allows the use of this method, which perhaps also in other countries may be found useful because there are certain applications which can only be solved by this method. Let's come to Part 1.9. Part 1.9, fatigue is in the phase 3. So here the project team has just finalized the document and their work. They handed over the document in the beginning of this month and also had a real big achievement in view of ease of use, more exact definition, harmonization with EN 1090 Part 2. They also improved the efficiency because there are now a distinction concerning the different notch effects. So for light notch effects, we have an increased resistance. The figures were improved in the detail table. Also, the detailed categories are partly updated. There is not only anymore the nominal stress method, but there is also an Annex B covering the hotspot stress method. and a new Annex C for the effective knot stresses. And we have a new annex dealing with post-weld treatment of high-frequency mechanical impact treatment. So we really tried also to open the gate for new developments. Here is an example. I'd like to give you a flavor of what this new figure looks like. You clearly see the much clearer. You see the stress distribution. There are the weld symbols included. So I think it's a real improvement we achieved. As a last point, I'd like to come to a new part 114, design assisted by finite element analysis. And in fact, in some parts of Eurocode 3, this was already possible. So there is at the moment an Annex C in Eurocode 3 Part 1.5, and the rules in Part 1.6, they allow for design assisted by finite elements or other numerical method. However, when we started the precision, there were also other working group and other parts who said, we want to have this method now included in our draft. And we decided to have one common part 114, really covering all the basics for all the different applications. And this was, for harmonization reason, I think a very good step, so that everybody really uses the same methods and the same expressions. This was drafted first by an ad hoc group, where the different working groups sent their representatives, and is now worked further in the working group 22, where all the countries have sent their expert in. They develop two documents, and I think this is also an important point. They develop the pure code. Only code rules are in the pure codes. It's the length of 50 pages or so, so relatively short, and a technical report on the background and commentary. And I think this is very important, that, for example, by this background and commentary, you also get help how to use these rules, for example, also by giving benchmark for recalculation. I like to give you some in-view in these features. So for me, a big advantage is now that we have a clear differentiation between validation and verification. Validation means the compare of the model with a real physical phenomena, and verification means the check in how far the model approximates the real mathematical solution. So these are two issues, and I think it is important to make this differentiation, because not in all cases both verifications and validations are necessary. And let's come to the next slide. Here, I think is also very important that Part 114 covers very different analysis purposes and has now a clear separation of that. There is on one hand this numerical simulation where, for example, with a complex model, tests are recalculated and then further tests are replaced by systematic parameter study with this numerical model. So this typically leads to code rules and is not for everyday use. The basis of that is, of course, measured values if it concerns recalculation, or mean values or distribution. On the other side, there is this numerical design calculation, which is for everyday use. And this is based very clearly only on nominal values. We have on one hand what is done everywhere at the moment, that we use numerical tools to calculate the internal stresses or the internal forces, and then take them to make the verification by the analytical rules of the application parts of Eurocode 3. However, I think already now in some cases we also have this second link, direct resistance check by a numerical model. So in this case, also within the numerical model, the verification is done by comparison, for example, the strain or the stress to a kind of limit value. Also in this case, we have nominal values where we start off, And concerning the partial factors, we have to achieve the same level of safety. Also, the same partial factors are used as in the normal verification according to the analytical rules. However, when we compare physical model and numerical model, there might be a need to implement, in this case, also an extra partial model factor to cover the difference between between numerical model and physical reality. So I think by part 114, we will have with part 114, we will really have a future-oriented tool to take care of the increasing importance of numerical calculations and ensure at the same time the same level of safety. And I think this is a very important point. Let me conclude. The aims we have are to have at the end harmonized and user-friendly design rules and ease of to use rules, especially for the standard cases, which I always call 80% cases. But of course, at the same case, we have to have the necessary basis for complex problems. The experience showed that we need the input of the practice especially, and by the input of the practice and by the comment, we really can improve the new codes by that. So let's work together, influence the development, and let's create codes for the future. Thank you for your attention.